Let's practice some of this exponent work. The main mistake I'm seeing on a few of your papers is you're making stuff up. And it's not because you know you're making stuff up, it's because you're doing stuff and not realizing you're not following the rules. So let's just go over the very few rules that you have. Very, very few. You just have to be very careful about how you work with them. So one of them is a to the m over a to the n. This is dividing. You have the same base. What's the base in this case in each numerator and denominator? A is the base. So what does this equal? Someone raise their hand and tell me what this equals. Jasmine. Exactly. What about a to the m times a to the n? What do you do there, Jacob? Yeah, a to the m plus n. Right, exactly. What about this? What's a to the negative n equal to? 1 over a to the n. What does a to the 0 equal? 1. There's only a few things you can do here. That's really all the new information that I've given you that should allow you to do it. There's a few, actually, you know what? Excuse me, there's one more. Sorry, I'm forgetting. What about this? A times b to the m. What does that equal? A to the what? M times. And remember, all of these are reversible. So if you see this, you can go backwards to that if you need to. Exactly. Nice. So you just have to be careful that you follow these rules. You also have to remember how to work with fractions and do division. So for example, if you had x to the 4th times y to the negative 2, that's not in most simplified form because it still has a negative exponent in it. What is y to the negative 2? 1 over to the 2. And if you have x to the 4th times 1 over y to the 2, what does that equal? Exactly. There would be your most simplified form because there's no negative exponents in it. Exactly. So what happens if I gave you this? Ready? A to the negative 3, b to the 4, c to the 9, d to the 7, over d to the 5, b to the 3rd, a to the 3, which one am I doing there? C to the 4. How would I simplify that? What should I do? Well, I'll give you a hint. If you do, what's b to the 4th over, sorry, that should be a, oh, sorry, I'm circling the wrong ones. Right here. What's b to the 4th over b to the 3rd? B to the what? 4 minus 3. Exactly. What is, let's do this one. How do you do this one? A to the negative 3 over a to the 3rd. It's going to be a to the negative 3 minus 3. Exactly. That one's right there. What about, let's say, c's right here? That's going to be c to the 9 minus 4. So c to the 5th, you're absolutely right. Yes, that's correct. And then what about the d's right here? D to the 7 minus 5. So what do you end up with? B to the 1. So you could just write b because you don't need the exponent. What about the next one? We do the a to the what? Negative 6. And what's the next one going to be? C to the 5. And what's the next one? D to the 2. So if we actually keep going here, you have b times, instead of a to the negative 6, if we want to keep going here, what's a going to be translated into? 1 over a to the 6th. And what do we do to the c? Oh, the c stays the same. And what happens to the d? The d stays the same. So what does the final answer turn out to be? B times what? C to the 5th times what? D to the square, all over a to the 6th. There you go. So if you use your exponent rules, you don't need to write up big complicated fractions. But you sometimes will have complicated fractions no matter what you do. So for example, let's say you had a over b all over c over d. What does that equal? A over b times what? D over c. So that's equal a d over bc. Exactly. Just remember, when you're dividing by a fraction, you're multiplying by the reciprocal. When you divide by anything, you're multiplying by the reciprocal, right? So for example, let's say you had y squared, I don't know, x squared over a squared all over 4. That's x squared over a squared times what? 1 over 4. So that's equal to x squared over 4 times a squared. So don't forget, don't remember anything now. Don't forget your basic fractions. So our final answers we're looking for should have no negative exponents, and they should only have at most one fraction in them. At most one fraction. So let's make one up here.
Can I have negative base numbers?
Sure. You can have negative numbers in them, absolutely. Just no negative exponents, and at most one fraction bar. right? So let's say I gave you this one. How about this? X z over y squared times 1 over x squared to the negative 3 all over x squared y to the negative 3 z squared, like this. Now, there's lots of different paths you can take. Is one direction, I just got one direction into math class. Is one specific path always the proper form? No, there's different. Can you start in different places with math problems? Sure. What should we do first on this one? What do you want to do on this one first? What do you want to do first if we're going to simplify this? Yeah, well, yeah. So let's look at the numerator first. Don't try to do everything at once. So what part of the numerator, the first, the second, or the third thing do you want to look at? The second one. So that's going to be x times z to the what power? 2 over y to the 2 times 1 over what? X to the what? Nope. X to the what? Come on, kids. Negative 6. You know that. Negative 3 times 2 is what? Negative 6. Great.
But when you have to do 1 times negative 3, you have to...
No, it's 1 to the negative 3 power, which we can do in there. But what 1 to any power is what? 1. You're right. It's 1 to the negative 3. Is it 1 times negative 3? No, it's 1 to the negative 3 power. What is 1 to any power? 1. So what's the can we do anything to the denominator right now? No. Let's just leave it like this. What can we do to the numerator? We're not done with the numerator here. What should we do now? Well, what's x times z squared over y squared? Actually do the multiplication. What's that going to turn into? Xz squared. What's 1 to the negative 3? What's 1 to the negative 3 power? 1 all over y squared x to the negative 6th all over what? The same thing. I did z to the z there, didn't I? That should be z what? Squared. Yep. So that's z squared. So which specific term should I try to work with right now? Which specific one? Let's look at the top. What's the one thing about the top that we don't really like right now? The negative 6. So what can we do with that negative 6? We can, well, we can simplify it a little bit. What is this going to turn into? X to the what power? 1 minus what? Negative 6 times z squared. What's still left? What's still left on the bottom? Oh, well, excuse me. Times y to the what power? You have to be really careful. It's over what? It's over what? Y squared, right? Do you see that, everybody? It's over y squared? Because it's still there. We haven't moved it anywhere yet. I'm doing not a very good job on this question. I'm sorry. But look, let's go back here. I'm trying to do too many things at once. Let's go back. Let's go back and take this very carefully. Are we okay with this right here? There's lots of different paths, and I'm trying to do too many things at once here. Let's just go from where we are right now, kids, which is if you're dividing by something, that's the same thing as multiplying by the. So this is the same thing as x to the first z squared over y squared x to the negative 6 times what? 1 over x squared y to the negative 3 z what? Squared. So what should we simplify first? Can we simplify the numerator or the denominator? What do you want to simplify? Well, the numerator just becomes x to the first z squared. What does the denominator become? What power is y being raised to in the denominator now? You have y squared and y to the what? Negative 1, and then x to the negative 6, and x squared, what's that? X to the 4, and then what's still left? Z what? Z squared. Okay. Do you notice anything that cancels? Z squareds cancel, leaving you with x to the first over y to the negative 1, x to the negative 4.
Can you just do that as x?
Ah, it's just x. I'm just putting the 1 there because when we do the subtraction, I want you not to forget that there's a 1. So what does this become? X to the first minus what? To the negative 4. And what's and then it's y to the negative 1 still in the what? The denominator, right? But you could jump it up to the top and make it. Do you remember that? You can make it y to the what? 1. Now, why is that? Let's just do this in pieces here. We'll leave that right there for now. What's x to the what's 1 minus negative 4? 5 over. So we're here. Are we okay with this so far? But what's the one thing that's not good about that? It's not finalized. We don't like the negative 1, right? Y to the negative 1 is what? So we have x to the fifth over 1 over y. That's equal to x to the fifth times the reciprocal of 1 over y. What's the reciprocal of 1 over y? Y over 1, which is just y. So our final answer is x to the fifth y. It's a lot of work. It's a lot of work, and you have to take it in pieces. Let's do one more. Let's say we had x to the third y squared to the negative 1 over x squared y to the third to the negative 2. Let's distribute the powers first. What does the top become? X to the negative 3, y to the negative 2 over x to the y to the Now you can break it down. It's going to be x to the negative 3 minus what? Negative 4. You have to be very careful, right? Y to the negative 2 minus what? Negative 6. So you end up with x to the what power? You can do it. 1. And y to the 4. Yeah, there's your answer. You can leave x to the first. That's fine. I'm not going to ever mark it wrong if you say x to the first. So collect all your terms on the top, collect all your terms on the bottom, and then do the subtraction if you're dividing. Then do it.